Pretty simple, isn't it? Basic component. It's basic numbers. It isn't simple. That's the problem. It's complicated. Okay, it is. It's complicated to get that relationship, to get that understanding. But without getting this baseline information right here in your book, did it give you a benchmark to go by? Did it tell you that when the smoke's to the floor, that you can have 500 degrees at mid wall and you can have fire on the ceiling? Did it tell you that you need to look to see that you have the appropriate amount of water? I gotta have two things to fight fire. What are the two things I gotta have to fight fire? Water and time. How do I determine that? I gotta determine the heat first. I gotta determine the heat first and understand the heat development. Okay, that heat development then gives me the relationship of what the structure is capable of doing, if it's withstanding, if it's beyond its rated life expectancy. Okay, so it tells me if the building's intact, then it tells me what the thermal balance is in the room, the heat development rate then that I can see. If I see smoke to the floor, what do I know the temperature is at mid-wall? Can be 500 degrees. If I have 500 degrees at mid-wall, what can be on the ceiling?
Fire.
If there's fire on the ceiling, what can happen? Okay? So when I know how, I have to have some way of determining what's taking place in that environment. Did I get a logical, sequential process for entering the structure from my reading?
No.
Okay. So I have to recognize what I did get. There's good information in here. A lot of the same science is in here, okay, is up here on this board. Okay? But it doesn't put it into a process that all of a sudden it breaks that down and says, hey guys, this is just one point in time. When you pull up, a lot of times you'll have a fire that will have the smoke to the floor in the structure. When the smoke's to the floor in the structure, what are you going to look for? Conditions that are going to do you harm. How do you recognize those conditions? By this science. And it keeps you ahead of that. When we put all these pieces together, it makes more sense. Okay, because we have to give you a little piece at a time to get you to start to grasp these pieces. Then we start adding the water to this, and we put all these pieces together on that entry procedure. It starts coming together more in a better, more comprehensive understanding. Okay? You guys have a noon lunch today?
Yeah.
Okay, any questions on what we looked at here, the science that we put together here?
I was just gonna ask how the with pressure, how the temperature correlates to when you fill on a door. Is it gonna be hampered a little bit, and the layer's gonna be lower inside the room?
Again, the rate at which that does and the rating on the door. Okay, so that gets into, again, ASTM E119. What is a 1 hour door? What is it rated to? 250 degrees. Okay, to transmit that 250 degrees with a certain amount of BTU rate per minute per square foot. What is a 3 hour door? 400 to 600 degrees. I mean, there's lots of, unless you have all the signs and variables, that read at the door is tough to do. Now, it doesn't mean I don't use it. And you will use it. You'll come to the door. I mean, that's, again, guys, this is where that gray matter comes into place. It has to make sense. If I come up to that door, okay, and it's a steel door and it's glowing red, what do you think?
Keep it hot.
Yeah. Okay. Comparatively, it has to make sense to me. So when I come up to that door, and I see that now I did my walk around. I see smoke to the floor. Okay, I know the fire that is. I can hear the popping and crackling in there. I can hear popping and cracking. Okay, and that fire I know is 15 feet from the door, and I know that I can hear a whole bunch of popping and cracking. What do I anticipate on that door? Probably some heat. You know, I see heavy smoke pouring out of the bottom of the door, heavy smoke pouring out the top of the door, the sides of the door, this thing's pressurized, this thing's pumping smoke out of there. If the smoke's being pumped out of there, what does that mean? Charles' laws kicked in, there's pressure because the gas volume is expanding, there's heat in there. that heat gun's gonna transfer the door. So I have to make some judgment, hey, that door's probably hot. So I just wanna slap my hand on that door? No, I don't. First thing I'm doing, I'm gonna come up to that door and I'm gonna see if there's any radiant energy off that door, okay? I can anticipate that, and then I can, if I have to, then I can touch the door. But typically, I don't even have to touch the door. Typically, I'll go, hey, yeah, it's hot. Typically, what I'm gonna do is we'll show you down here, when I get to that condition, I'm gonna check that, what am I gonna do first? Check that door, see if it's unlocked. If it's unlocked, pop, crack the door. Now if I stick my hand in there, what can I feel? Now I can feel that heat, even the door crack. I can get an anticipation of what's gonna start to get my information of what's taking place in there, okay? That's what I'm gonna do. Okay, now in those cases where I can't, then I'm gonna use that door. If it's a wall, then I'm gonna put my hand against that wall, see if it meets that definition for extension. Okay? Now, remember I was talking, we hadn't finished my point on this 450 square foot in that 1 minute, okay? And we'll go over this a couple more times. But let's pick that 1 minute. Now we have this information right here. Let's see how ugly this thing looks. Let's pick this thing out and see what this looks like on that 450 square foot fire. Okay, I'm not gonna take and it took 8 minutes for you guys to arrive and 2 minutes for you guys to enter. So I'm not gonna use that first 10 minutes. All that fire burning for that 400 to engulf that 450 square foot, I'm not even gonna count. Okay, so that fire's been 450 square foot, been burning there for 10 minutes. I'm not gonna count any of that heat. Okay, I'm only gonna take 1 minute of that heat. I'm gonna take the 11th minute of the heat. Okay, the 11th minute of that heat. Okay, so in 1 minute, how much heat is gonna be released from that fire? What's the answer? Take the 4,800 and do what? Divide it by 37. I get 130 cubic feet of air. Now I take 130 and I multiply that times 450. What do I get? 58,500 cubic foot of heat. How much room did I have? 3,600. There's 58,000 cubic foot of heat is released, and I have 3,600 cubic foot of room. What do you think it's gonna feel like in there? Now, even if I take the other 3,600 and add that to it, the 7,200 that would have evolved. Now I take 7,200 and 58,000 into 7,200, what's it gonna be in there? Hot. And that's only 1 minute. That's 1 minute in that time. That didn't count the other 10 minutes in front of that. Okay, so when that fire gets up there at or near your flow capacity, at or near your ability to enter that building, you better have your game on. You better know what you're doing. This is where, guys, this is where we get into trouble. If it's a garbage can fire, it's no big deal. But with that rate of heat release rate and that amount of energy coming out of that fire, it can smoke you in no time. It can go beyond your capability. I like to draw that last correlation I like to draw on that is that fire, when that fire is burning, it's 1,400 degrees. What temperature do you burn at? 118. How many times greater is that? Over 10. Now, if you take that same thing, you got, and I can military press 150 pounds. Now I take that 10 times that. What is that? 1,500. What do you think that 1,500 is going to do to me? It's going to drive me through the ground. That's what that heat in that fire is going to do. It's going to smoke you. Okay? You lose your ability to keep in a safe proximity to that fire, and you're going to pay the price. Okay? You're not going to be able to get out. Not only that, then when you use your water, you're going to pay your price again. If you don't know your relationship to your fire. And we're going to explain that a little bit towards the end of the day here on that relationship and how those pieces come together. Okay, but you have to understand your relationship to fire, and you can't understand your relationship to fire unless we understand the fire behavior. Okay, that's a rough overview for this morning. We're going to cover back over this thing again this afternoon.
Anybody want to volunteer to describe fire behavior when they come back with all the numbers? No? No volunteers yet?
Okay, lunchtime.
Yep.
Attention. We're going to
dismissed.
Absolutely.